Hi everyone. Good afternoon. Good evening to everyone. Now today we are going to study about the question number 44. It's all about center of mass. So how to find center of mass? Now the very first thing is, what is the meaning of center of mass? See, center of mass is a point which behaves that all the mass is concentrated at that point. So it appears to be, not originally, it appears like all the mass is concentrated or located at that one particular point. That point we call it as center of mass. Or you can say, like, when you apply force on a rigid body such that it should perform, means you have to apply the force on a particular point such that it should move or it should perform translatory motion, then we can say that that point is center of mass. Now, when you consider a system of n point particles like M1, M2, M3. Now, whenever you want to find the position of center of mass for any system, you must be having one coordinate system. Then, if you take the positions of each particle, then position of center of mass is given by M1 R1 bar plus M2 R2 bar so on, Mn Rn bar by M1 plus M2 plus so on Mn. So there must be one position for center of mass also. Now, so when they give the position vector, then you can use this formula. But sometimes they will give the coordinates, like M1 coordinates are x1, y1, z1. And M2 coordinates are x2, y2, z2. Similar way, xn, yn, zn. Then there is one xcm, there is one ycm, there is one zcm also. Like xcm means m1 x1 plus so on, m2 x2 plus so on, mn xn whole divided by m1 plus m2 plus so on, mn. Similarly, when you want to find y coordinate of the center of mass, then m1 y1 so on, mn yn by total mass. But here, every time they may not give the coordinates. You may have to imagine the coordinate axis, coordinate system on your own depending upon the question, and you may have to find the coordinates according to the given question. So they may give the coordinates, they may not give the coordinates. But after finding the coordinates, you can find the coordinates of center of mass. Now one more thing, when there are only two particle system like M1 and M2, you can take any one is reference, or their center of mass is somewhere at a distance R1 from M1, R2 for M2, and the separation between them is D. Then R1 is M2D by M1 plus M2, and R2 is M1D by M1 plus M2. So you take any one point as reference and you try to find the coordinate, then you will get the values of R1 and R2. Suppose you have taken center of mass as reference, then the coordinates of center of mass will become 0, 0. And the coordinates of M1, M2 will become like M1 is minus R1, 0 because it is on negative x-axis it will become. M2 will become on positive x-axis. So the coordinates will become R2, 0. So in that way, you can find the distance of center of mass from M1 and M2, that is R1, R2. So based on these simple things, they can ask the questions. Let's see a few examples like how the question can be asked. Now here, four particles of masses 1 kg, 2 kg, 3 kg and 4 kg are placed at four corners of a square of side 1 meter. If 1 kg is taken as the origin, now this is the origin, then this is our x-axis and this is our y-axis. Now for 1 kg, it is at origin, so 0, 0. It is only xy plane, so only two coordinates will be there. 2 kg is on x-axis, so that is 1, 0 because this length is 1. Now 4 kg is on y-axis, so 0, 1. And 3 kg is in xy plane, that is x is 1, y is 1. So 1, 1 because this is 1 and this is also 1. Now after that you can find xcm, that is m1 x1 0, m2 x2 2, m3 x3 0, m4 x4 3 by m1 plus m2 plus m3, that is 10. So that 1 by 2. Similarly ycm 0 plus 0 plus 4 plus 3 by 10, that is 0.7. So what are the coordinates of center of mass? 0.5, 0.7. Now, the center of mass of three particle system is 3, 3. Where should be the fourth mass of 4 kg be placed so that the center of mass of four particles be at 1, 1. Now these three particles, see 1, 2 and 3 kg, center of mass is 3, 3. Then you can replace like it is like a single mass of 6 kg at 3, 3. Another one is 4 kg at what point we don't know. Let's say x, y. And their center of mass is at 1, 1. Then x coordinate 1 equal to m1 x1 6 3 is 18 plus 4x by 10. Then if you solve it, x will become 2. Sorry, minus 2. Similarly, YCM if you take, YCM also 1. That is 6 into 3 plus 4 into Y. Again 6 plus 4, 10. Then Y also you will get it as minus 2. So minus 2, minus 2. So that way you need to understand. Here in the second question, the question is little bit different. And you have to understand one thing, that as 1 kg, 2 kg, 3 kg center of mass given, you can consider together as one particle because that all mass appears to be concentrated at that point. Now, the distance between the centers of carbon and oxygen atoms in carbon monoxide has gas molecule is. Now the distance between them is, one is carbon, one is oxygen. The total distance between them is 1.127 into 10 power minus 10 meter. Now the center of mass of the molecule is located at a distance of. Now the center of mass of the molecule is located at from carbon or from oxygen. So here you take carbon, here you take oxygen and the distance is D. Now let's take, it is at a distance R1. Now this is the center of mass. It is at a distance R2 from O. Just like I explained, two particle system. Now from carbon means R1 is mass of oxygen into D by mass of oxygen plus mass of carbon. And R2 is mass of, means from oxygen, that is mass of carbon into D by mass of oxygen plus mass of carbon. So if you find R1, R2, then you will come to know which option is suitable. Now if two identical particles are at 2, 3, 4 and 6, 3, 2, then coordinates of center of mass of the system are. So two identical particle means the center of mass must lie in between them actually. Exactly midpoint, mm. Now one is at 2, 3, 4. Another is at 6, 3, 2. Now center of mass is somewhere. Now the XCM is m into 2 plus m into 6 by m plus m. That is 8 by 2. Get cancelled. So 4. Next, similarly, YCM also, when you consider m into 2 plus m into 3 by m plus m, that is 5 by 2, that is 2.5. Sorry, this is 3. So 6 by 2, that is 3 will become. Then similarly, ZCM equal to, so Z is 4. So 4m plus 2m by 2, that is again 3 will come. So 4 comma 3 comma 3. Now the next thing is 3 particles of masses 1 kg, comma 2 kg and 3 kg placed at the corners of an equilateral triangle of 1 meter side. Then coordinates of center of mass assuming 1 kg mass at origin and the line joining 1 kg and 2 kg lie on x-axis. So now there is a equilateral triangle. Now you have to consider 1 kg is at origin and 1 kg, 2 kg is on x-axis. Then this will become what? Y-axis. Now coordinates of 1 kg is simple. It is at origin 0, 0. 2 kg also simple. It is on x-axis. And the side length is 1 meter. So 1, 0. Because as I said that they may not give the coordinates. Depending on the given question, you may have to choose the coordinates. And the only little bit difficult is 3 kg. 3 kg when you consider the y coordinate is height and the x coordinate is half. So 1 by 2 comma h. Now if you take this triangle, this is height, this is 1 meter, this is 1 by 2. Now h square equal to 1 square minus 1 by 2 whole square. So h square equal to 3 by 4. So h equal to root 3 by 2. Our height of equilateral triangle is well known thing. If you can remember, then it will be very good. Then they are asking the coordinates of center of mass. Then you will take XCM, YCM, ZCM one by one. Like 1 I will find it. XCM equal to M1, X1, 0, M2, X2, 2, plus M3, X3, 3 by 2, by M1 plus M2, 6. That is 7 by 12. Similarly, you can find YCM also ZCM. So this is how you have to deal with the center of mass of point particle, system of point masses, n point masses. Also, the center of mass of two particle system separated by a distance d. And based on the same thing, I have given the assignment questions also. Please just try to solve, practice it. So then you will get the idea. So this is all about the basic question which can be asked based on the center of mass of system of n point masses. So thank you all of you. We'll continue in the next session with the next lecture.